Hi everybody, we're going to review the answers for the lab problems from chapter 5, question 2, A through D, 6A and B, 12, 14, and 18. 2 is an interesting question I find because most students want it to be way harder than it is. It's a very, very simple one. You don't need the formula. In fact, you can't really even use the formula. You don't have enough information, and that's what students want to do. It's just a matter of sort of a logic issue. It tells us that for a population with a standard deviation of 20, that find the z-score for each of the following locations, above the mean by 5, so on and so forth. We don't have a raw score. We don't have the mean. All we've got is the standard deviation. We don't have enough to compute any z-scores. But what we have is the power of logic. So we know that an entire standard deviation, again, is going to cover a total of 20 points. So A says we are above the mean by 5 points. So let's stop to consider that if we're above the mean, our z-score has to be positive, right? And we're above the mean by 5 points. Well, if a whole standard deviation is 20 points, right? If we went up a whole standard deviation, we would have gone up 20 points. Our z-score would be positive 1. But we didn't go up 20 points. We only went up 5 points. We went up only a quarter of a standard deviation, 5 out of 20. We moved 5 points out of the possible 20. So 5 divided by our 20, what we have is a z of positive 0.25. We are a quarter of a standard deviation above the mean. For B, above the mean by 2 points. Well, if we're above the mean, it's got to be positive. And now we only went 2 points, 2 out of 20. Well, 2 out of 20 is positive 0.10. For C, it says we're below the mean by 10. Below means it's negative. And we moved 10 out of 20 possible points, so we have a negative half. And the last one says that we're below the mean by 30 points. So now we've gone more than a whole standard deviation. We moved 20 plus an extra 10. So 30 out of 20 is 1.5. So didn't need a formula, just needed to sort of remember that a standard deviation is measuring distance, and it says, well, you went 5 points out of the 20. If you lived 20 miles from work and you drove 5 miles of it, how far did you go? A quarter of the way, right? That's all this is. So those are the answers for question number 2. For question number 6, A and B, it's just a matter of turning raw scores into z-scores and z-scores back into raw scores. So for 6A, the answers are a z of 0.25, 0.40, 0.75, negative 0.50, negative 0.10, and negative 0.70. So these are the answers that you should find for 6A. For 6B, going the other way, we have raw scores of 70, 100, 60, 105, 65, 142. I'm not obviously walking us through every one of these calculations. That's what the lecture videos are for. If you find that despite your best efforts, these are not the answers you're getting, then you know what to do. It's time to reach out to me and say, hey, Paul, how come my formula isn't working for me? And we can see about sorting that out. But it should be just a matter of plugging the information into the formula, and these should be the answers you see as a result. Now, 12. Question 12 requires, again, for us to employ a bit of mathematical reasoning, a bit of mathematical logic. It says a score that is 12 points below the mean corresponds to a z-score of negative 1.5. What's the standard deviation? So for question 12, if we are saying, let's think about pretty pictures here. Put our standard deviation lines in here. And it says right there that if we go to a z of negative 1.50, if we go right there to a negative 1.50, that is 12 points below the mean. That this distance is 12 points away. So notice what we're learning here. We're learning that 12 points of distance is the same thing as 1.5 standard deviations. Now, remember, the negative just tells us that it's on the left. Distance is always positive. When we move 12 points of distance, we have moved 1.5 standard deviations of distance. Then again, the negative just says we move that way for it. So 12 raw score points is the same as 1.5 standard deviation points. So all we have to do is basic algebra. Divide both sides by 1.5, so that cancels out. And what we find is that a standard deviation is worth 8 points. So that's 12. 14, it's a similar kind of a problem in that it's the same sort of a logic. We're trying to relate distances to each other, equate distances. So for 14, we're told that we have a population with a standard deviation of 14 points, and that a raw score of 24 corresponds to a z-score of -0.5. Now what we're trying to find is what's the population mean. So again, let's throw ourselves up a little graph to do some thinking with here. Put some lines in it to help guide our markings. And so what we want to find out is what the raw score mean is. We want to find out what raw score value goes right there at the z-score of 0, right? So it says that we know that a standard deviation is 14 points. So we know if we go a full standard deviation, that's 14 raw score points. It tells us that a raw score of 24 equals a z of -0.5. So it tells us that if we go to a z-score of -0.5, that score is 24. Well, if we go down a full standard deviation and we've gone down 14 points, if we only go half of that distance, how many raw score points did we move? Half of 14 is 7. Well, we know that where this little line here is, that's the raw score of 24. We know that we've gone 7 points below the mean to get there. So to get back up to the mean, we have to go back up 7 points. Therefore, the mean is 31. 31 and 24 are 7 points apart. So that was question 14. Now for 14, you could have also worked a formula, plugged things and solved it in that more algebraic way. Whichever way you solved it is fine with me, as long as you got the answer of population mean of 31 points. And then our last item for the Chapter 5 lab is question 18. Question 18 says, in a population distribution, a raw score of 57 corresponds to a z of -0.25. It says that a raw score of 87 corresponds to a z of 1.25. Find the mean and standard deviation. Hint, sketch the distribution and locate the two scores in your sketch. As I mentioned before, whenever there's a hint, take it. So it's telling us that a picture will help us find our answer. So get our z-scores plotted in there. So what do we know? We know that if we go to a z of -0.25, so a quarter of a standard deviation, that raw score, we've been told, is 57. Now, we're also told that if we go up to a z of 1.25, the raw score there is an 87. So the math here works a lot more like question 12 ultimately. So let's start by asking ourselves, how far apart are these two scores? Well, the high score is 87, the low score is 57, so how many points apart are they? That these two scores are 30 points apart. Now, how many standard deviations apart are they? Well, to the right, it's 1¼ standard deviations. The z-score to the left was negative 0.25, but remember, standard deviations are always positive. It's distance. So we go another 0.25 over here. So 1¼ plus another quarter is 1½ standard deviations. Coincidentally, the same number from question 14. So we do the same thing. If 1½ standard deviations is 30 points, how much is just 1? Well, let's cancel out the 1½. And we find that a value for a standard deviation is 20 points. Well, that's one of the answers we were asked to get. What is the mean and standard deviation? We now know standard deviation is 20. Now we can use that. We can either go up from the low score or down from the high score back towards the mean. But we now know that one standard deviation is 20 points. So let's go with the low side, where we've moved 1/4 of a standard deviation. Well, what's 1/4 of 20? 1/4 of 20. And again, you could plug these into formulas if you wanted to, but we're trying to get the logic here. 1/4 of 20, 1/4 of 20 is 5. So that tells us that there's 5 points there. So and to go 57 back up to the mean, I have to go up 5 more points. So 57, 58, 59, 60, 61, 62. 62. And so now we know that mean is 62. So again, we could have tucked this into formulas that we've got some of the pieces, work some out, and then go with the calculator approach. You can do it either way you want, like we saw in the lecture videos. You can go more graphic or more formula, depending on the problem. Sometimes you have to do it one way or the other, but we've got a choice. It's up to you, whatever thinking tools you want to use. So as always, if you've got questions, if something here didn't make sense for you, reach out for some help, and I'll be happy to see what I can do to get you to the finish line on that. All right.